Hi everyone, it's me Javindra Paudil. Today in this video, I'm going to create the geometric model of the building structure in Midas Gen. This is the Midas working window. We see different menus here in Midas like view, structure, node elements, properties, boundary, load analysis, and so on. So let me start with the creating the grids in Midas. Here, before creating the grids, we should care for the unit in which we are going to model the structure. The force unit here is kg, ton, newton, kilonewton, kips, and this is the displacement unit, distance unit, which is in mm, cm, meter, feet, and inch. So now let me put newton and meter for the force and displacement unit. And we see here U means user coordinate system and G means global coordinate system. So at first, let me go to grid. Here are two options. One is point grid and the next one is the line grid. So let me click the point grid. Suppose if I put the distance for or spacing of one in both x and y direction, here is uh, given as dx and dy as 1 comma 1. Similarly for model boundary 0 0 and 10 10, 0 means the minimum value and 10 is the maximum value. Then if we tick the apply to grid boundary, we can see the grid point of 10 meter into 10 meter distance at the spacing of 1 meter. And if we click here, the cursor snap is at the rate of 1 meter distance, center to center distance. So if we uncheck this, the grid appears like this. So these grid points are used to create the line element or any element of certain length. Here we can create the element. Suppose the spacing of each grid point is 1 meter. So the element can be created as 1 meter, 2 meter, 3 meter, or in whole number length. And if we put here 0.5 or 0.5, and the element can be created as, for example, 2.5 meter, the length 3.5 meter, and so on. Accordingly, the grid point can be created. So for now, let me go to the line grid. Let me go to line grid, go to add, give some name, grid AA, let's write, and let me add grid at extrude line. There are two options, one is absolute and another one is relative. You can choose either of them. So for now, let me put 4 meter along the x, 3.5, and another one is 4. Let me click OK. Then we see here the addition of grid lines, and in y-axis 3.5 at the rate of 3. Oh no, 3 grid lines at the spacing of 3.5 meter, 3.5 equal spacing of 3.5 meter. Okay, the first one is 4, 3.5, 4 in x direction, and the second one in y direction is 3.5 equal. So let me click OK, apply. Okay, here we see the grid lines of 4 meter, 3.5 meter, and 4 meter in x and 3.5 each in y direction. So in Midas Gen, to create the elements, first of all we have to create the nodes. So let me start with the node element. We see here node element. Here let me click at the intersection of this grid line. We can see the node is created here, similarly here and here. It is snapped at the grid lines, and these nodes can be translated in either direction. Another option is to create node here, like what we have done in this first phase, and another one is to translate these nodes. So let me first translate this node. First of all, let me select these 4 node, and here translate node appears in the tree menu. This tree menu is very helpful in the modeling phase or in overall Midas Gen software. We see here we have to copy the nodes. So Let me click. Here is the active screen. This colored screen means it is an active screen, and we have to work on this tab. Sorry, active tab, and we have to work on this tab. Let me write 4, then number of times 1, apply. Okay. So here we see the nodes are copied in uh, another grid line. And similarly, let me again click this one, translate 3.5, apply. Then again, let me select this 4, apply. Okay. So like this, the nodes are created. And after the node has been created, let me go to create element. The element like beam, columns, shear walls, slabs, etc. they can be created by the two ways or modeled by the two ways in Midas Gen. The first one is to create element or connect the element from node to node, and second and easy option to create the element is extrude tab. So now let me go to extrude. Here the type of extrude here in Midas Gen, the first one is to node from node to line element. We can extrude this node to line element, and the line element to planar element, and planar element to solid element. So now let me click node to line element. So in element attribute, we see here the element type as beams, cross, tension only members, and compression only members. There is no separate tab for column because we know that column is a vertical member with a 6 degree of freedom, and the beam is a horizontal member. And these here in Midas, the beams and columns are separated by the horizontal and vertical position of the beam member. So for column also, we have to use the node to line element as a beam. So for now, we have not defined any material. Let me go to node to line element. Let me select all these nodes. Suppose we have a floor height of 3 meter, 3 meter, then these nodes are extruded as a column element, vertical element up to 3 meter height. So let me number of times for now, let me put 1 and click on apply. Oh, we see here we have put the translation mode at x-axis, but for vertical element we have to go for 0, 0, 3. It means z-axis. Let me undo this. Again, let me select and let me click apply. So here we see from the elevation, we see the node element are extruded as vertical line element. And if we see the 3D view, we can see like this. Similarly, these are the vertical members or column members. So again, let me select these nodes and extrude as node to beam element. So first of all, I select the node and go to extrude, same node to line element extrude type, the beam element. Here this is 4 meter in spacing, and this is 3.5, and this is 4. We have to go for unequal distance along the x axis, 4 comma 3.5 comma 4, and let me click on apply, and we see that the beams are along the x directions. The nodes are created as line element. Again, if we click, if we check these beams in this direction, these nodes, and let me go at equal distance, because in this direction there is equal distance of 4 meter grid, 1 2 3 3 times. So let me check. Sorry, this is the spacing of along the 3.5 meter along y direction. So let me go to undo, again select the nodes, 1 2 3 4, Let me go to 3.5 meter in 3 grid lines. Okay. Then these are the horizontal and vertical members. Suppose this building I have to model for 5-story. So let me select the entire nodes and element, then go to structure, go to control data. Here is a tab called building generation. So here in building generation tab, so let me go for 4 because we have one already from the base, which will become a 5-story. Then the distance of 3 meter. This is also 3 meter. So let me keep the 3 meter. Then go to add and click on apply. So we see the 5-story building model is created. We have not assigned any material properties or element properties. Only the geometry has been created. We see here this is supposed to be base, first floor, second, third, fourth, fifth. So again, go to control data. Here we use zero ground level as a 0. We see here this is assume as 0, or we can assume whatever we need or according to the necessity. And let me click OK. Again, let me go to story. Here, after creating the building model for the desired story, the story height or story data will be automatically generated by the Midas Gen, by the software itself. So we see a story for wind as well as seismic. So first of all, let me close this one and create a. So again, go to story. We see here the ground level is 0. We have already set up this, and let me click auto generate story data. So the data will be automatically generated according to this model, and which includes 5% of line dimension accuracy for inclusion of seismic accidental eccentricity and 15% for the inclusion of wind eccentricity. So let me click OK. Similarly, after creating the story data for wind is automatically calculated. For example, the width of the floor is 11.5 meter in X and 10.5 meter in Y direction, and floor center is 5.25 and 5.75, and eccentricity is 1.73 and 1.57 meter. These data are needed for the case of application of wind loading. Similarly, if we go to seismic, these are the parameters calculated by the software itself after creating the story data. So let me click close. Here in story data, the floor height is this one, and for the case of base, we can put ground level. Similarly, we can edit this as 1, story 1, 2, 3, 4, 5 here. So this story name can be imported from the types, sorry, Excel file also. Here, if we see the floor diaphragm, the flow diaphragm is considered here. Here is option for consider and do not consider. Here in this present case, we have not model any slab here. And in Midas Gen, if we do not model the slabs, the floor diaphragm is a rigid diaphragm. So we have to keep here consider the rigid diaphragm. And if we have to model the slabs, or if the slab is considered, then no need to consider the rigid floor, and we can do it as do not consider. It means the semi-rigid diaphragm can be assigned automatically if we consider or if we model the slabs in Midas Gen. So for now, I will keep so diaphragm as a rigid, and I will change later, and we will model the slabs as well. So let me turn into structure type. This is a 3D structure, and in the mass control parameter, lumped mass, and another one is convert self weight into masses. So in seismic analysis, the seismic force or lateral force can be generally applied to X and Y direction. So if we have to apply the seismic force up to on Z direction, we have to go to convert to XYZ. For now, in most of the cases, the seismic force is applied in x and y direction, so it can be clicked to OK. And if the seismic force is applied only to z direction or vertical direction, then we can go for this convert to z option. And in most of the cases, please select to convert to x and y coordinates, as the seismic force is applied laterally in x and y direction respectively. So the gravity acceleration is 9.806 meter per second square. These are the aligned top of the beam section with the center necessary for panel zone offset. So if we check this, the panel zone offset is considered, and if we do not check this or take this, the panel zone is not considered in the analysis. So this is the structure type. In the next video, we'll learn how to create the slab elements or how to extrude the slab elements in this model, define the material and section properties, as well as boundary condition or assigning support for the structure, and so on. So till then, keep watching these videos. Don't forget to like, comment, share, and subscribe my YouTube channel. Thank you.